Next, units and dimensions. Units. What do you mean by unit? Yes, it is the standard reference of a physical quantity which distinguishes that particular physical quantity from other physical quantities. So length is equal to some 2 meters, some time is equal to 8 seconds, so mass is equal to 3 kg. So meter is the unit for length, second is the unit for time, and kg, kilogram, is the unit for mass. Suppose if you take L is equal to 2 meter, you can convert into centimeters. What do you write? 200 centimeter, and in millimeter 2000 millimeter. So value of L does not change. 2 meters is same as 200 centimeter, is same as 2000 millimeters. Here numerical value is going on increasing and the size of this unit gradually decreases, but the product is same. That means NU is constant. What is N value here? Numerical value. U is unit. This value is constant. So we can write N1 U1 is equal to N2 U2, or U is inversely proportional to N, or N is inversely proportional to U. So N1 U1 is equal to N2 U2. This is very important relation we are going to use while solving problems. N for numerical, U for unit. Now we are having 7 physical quantities, fundamental physical quantities. Now let us go for dimensions. All the physical quantities we are going to divide into 2 parts. One is fundamental physical quantities, another is derived physical quantities. What do you mean by fundamental physical quantities? Whose measurement does not depend on any other physical quantity is called fundamental physical quantity. And we are having 7 fundamental physical quantities. Seven fundamental physical quantities, those are mass, and next length, time, temperature, current, electric current, luminous intensity, and quantity of matter, and the units of all these physical quantities are kilogram, that is kg, length meter, time second, temperature Kelvin, electric current ampere, luminous intensity candela, quantity of matter is mole. Now dimensional formula of these physical quantities, fundamental physical quantities are: for mass dimensional formula is capital M, for length capital L, for time capital T, for temperature capital K, or sometimes we use theta, for electric current capital A, or sometimes we use I, for luminous intensity CD, for quantity of matter mole is the dimensional formula. These 7 physical quantities are called fundamental physical quantities or base physical quantities. Why we are calling those physical quantities fundamental physical quantities? Because these physical quantities measurement does not depend on other physical quantities. That is the reason why I am calling these physical quantities as fundamental physical quantities. Next, some substitution quantities are there. One is plane angle and a solid angle, and its unit is radian, its unit is steradian.